All right, let's take a look at our lesson on absolute value inequalities. So we have a couple of different things going on here for our absolute value inequality, and it's really significant depending on which one you have. First of all, you need to isolate, before you make the judgment, you need to isolate the absolute value part. You need to get it by itself. Once we isolate, we'll just put a little circle. Once we isolate the absolute value parts, then we make our decision whether this is going to be an and or an or. So if once you get this isolated, the inequality sign is a greater sign, then you have this or situation. So let's look and see how we translate the or, because we can't really solve the absolute value inequality with the absolute value bars there. That's really just not a thing. We need to get rid of them. In order to get rid of them, we have to transform them into their form without absolute value bars. So for this first one, what we would do is, the way I like to think about it is we would write this exactly what it looks like, this inequality, without the absolute value bars. See how these are the same? Right here. Then our second option, the other option, or the or, we would write this left side the same and then switch the greater to a less than and change whatever is over here to the opposite. And that's how we would translate a greater or or. All right, let's look at the other option. What if, once we've isolated the absolute value, we have a less than sign, that the absolute value is less than some items over here on the right? Well, a less than sign can be, split up like this, where, you have the ax plus b is greater than negative c and the x plus b is less than c. What I like to do, what makes sense to me, is to set it up like this. And then I would look at each piece. So I would do this one. As you can see, this is this first one right here. And then I would then solve this piece, and that is this second one right here. So really it's up to you on how you rewrite it. I'm going to, of the less than or ands, I'm going to rewrite it like this and then split it into two different inequalities. So what is the big deal about the or and the and? Well, an or signifies a union, and a union is where all items in the solution are the answer. All items in the solution. The and is an intersection, and that means that only items in common are the answer, or the solution or answer. Okay, so that's really important. All right, so let's jump in and let's work some examples and see, how this works. So we can't really notice this is a less than, but we don't know. We really don't want to make that, case yet until we get that absolute value piece isolated. So I'm going to move the 2 over, and then I'm just going to give me 11, absolute value 11 minus x is less than 20. Okay, great. It is a less than or an and. So what I'm going to do is I'm going to set it up like I was telling you, like a sandwich. And then I'm going to take this first piece, I'm going to solve it, and then I'm going to use the middle twice, I'm going to solve each of these inequalities separately. All right, so I really, instead of worrying about dividing by negatives, I would really rather move this x over to the left side. So I'm going to add that to both sides, and that gives me an x is less than, and then I'm going to move the 20 over, which 20 and 11 gives me 31. So for one piece of this, I have x is less than 31. The other piece, again, I want to keep the x positive instead of worrying about dividing by negative and flipping the inequalities. So I'm going to move the x over here, and then I'm going to move the 20 over. 11 minus 20 is negative 9. So now we've got to graph this on a number line so we can determine what our answer is. Remember, the less than, this is an and, which means this is going to be an intersection. So only what is common to each of these inequalities is going to be the answer. So x needs to be less than 31. Okay, that's open. It needs to go this way. And x needs to be greater than negative 9, which goes this way. And we can see that the only things that are the same in these two solutions are these items that are in the middle. So our answer, we can write two different ways. We can write a set notation, so our little squigglies, all x such that x is between negative 9 and 31. That's one option. Or we could write it in interval notation, negative 9 to 31. And that's our first solution. We could do either of these. What's important is it's really important that we graph it so we know what the solution is. All right, so let's take a look at our second equation, our inequality. This 2 right here, we really can't have that there. It's the absolute value piece is not isolated. So we would need to divide both sides by negative 2. And I hope you remember from your previous work with algebra that when we divide across an inequality by a negative number, multiply or divide by a negative number, it causes the inequality sign to flip, to go the other way. All right, so this is important because if we hadn't done that, we would think this would be a greater or, but it's not. It's a less than and. So again, I'm going to do what helps me, my favorite thing. I change the sign, switch 3x plus 4. Okay, and then I'm going to split it into 2. So I've got 5 is less than or equal to 3x plus 4. 3x plus 4 is less than or equal to negative 5. Okay, and this is also an and. We'll just make a note there. Remember, and means intersection. All right, so let's solve these, each one. So I move the 4 over. I get 3x is greater than or equal to 1. Then x is greater than or equal to 1/3. Okay, working on this one, move the 4 over, x less than or equal to negative 9, x less than or equal to negative 3. All right, so let's graph it, see what happens. So I got a negative 3 and I got a 1/3. So x is greater than or equal to 1/3. Okay, it goes that way. X is less than or equal to negative 3. Goes that way. Okay, so let's think about this. So it's an and it has to be the intersection of those two inequalities, but they don't intersect. They don't ever cross. So this would be an example of a no solution. Okay, the result of this number line would make, basically the result is a no solution because they don't cross anywhere. Okay. All right, great. We have a couple more examples on the next page, and then we'll be ready to run with this. So this is a greater. It's already, the absolute value piece is already isolated. This is an or, greater or. So this is This is a union, which means it doesn't matter what, everything is going to be the answer. All right, so here we go. So let's translate it. If you remember translating the unions, it's write it exactly like it looks. And then, or we take the absolute value piece, the stuff inside, which is 7 plus 8x. Then I'm going to flip the inequality around and do the opposite of this right side. All right, so let's solve each one. So I have 8x is greater than -2, so x is greater than -1/4. Then we have 8x is less than, moving the 7 over, I get a -12, or x is less than, let's see, 12/8 would be, what, 3/2? Do the number line because, we need to do that. Let's see, we've got -3/2 is smaller, -1/4. So we want to be bigger than -1/4 and smaller than -3/2. Now, if this were a less than or an and, this would also be a no solution. But since it's a greater or it's a union, so basically all of that information is correct. All of it is part of the solution. And I want to make a note here. See how I've done hollow circles here? I want to remind you, remember the hollow circles because there's no extra equal sign under here. The one that we just did, see how there's the extra equal, greater or equal, less than or equal. So those are the solid dots or points. Okay, so our answer, if we want to write it in interval notation, well, this is set notation, all x such that x is greater than -1/4 or x is less than -3/2. If we want to do interval notation, we'd have -∞ to -3/2. You could do the union sign, which is that little U thing, or you could say or. Then we go -1/4 to infinity. All right, great. One more. So let's isolate the absolute value, divide by 3. 27 divided by 3 is 9. So this is a less than or an and. Okay, so let's split it apart. So I have -9 less than x plus 1 less than 9. I like writing these, separating them into two inequalities. There are ways to do this without having to separate them. That's just a choice, but I just want to separate them. It's easier. Move the 1 over. I have x is larger than -10. Move that 1 over to the right, and I have x is smaller than 8. So let's see what that looks like. So I got a -10 and an 8. Let's see, x is smaller than 8, and x is bigger than -10. This is a classic and. Again, we note that they're only the same right here in the middle. So my solution, if we were in set notation, all x such that -10 less than x less than 8. Or if we're in interval notation, it would be -10 to 8. All right, fantastic. Now that finishes up our lesson on absolute value inequalities.